So welcome back. We were looking at factoring prime numbers, factoring whole numbers actually into prime components. So we actually haven't done any factoring of polynomials yet. So we want to begin that in this second video. So the first method of factoring we're going to look at is called greatest common factoring, or GCF. Greatest common factor. Greatest common factor. So let's say we have the following. 5a cubed b minus 25ab squared. So I have an algebraic expression. Actually, I have a binomial, right? And what I want to do, I want to factor out anything that's in common. I want to factor out the greatest thing that's in common between the two terms. So first I'm going to look at the constants, or the numbers. So 5 and 25. Is there anything in common? Is there anything that can be divided out between 5 and 25? What is the largest number that can be divided between 5 and 25? How about 5, right? They're both divisible by 5, and that's the largest number. Then you want to look at the A components. And to figure out what, so we know there are some A's in common here, right? They both have an A. Now you want the largest power of A that's common between the two. And actually the way to do that, you look at the first power, which is 3, and then the power on the second component, which is the power of 1, right? And you actually take the smaller of the two. It turns out that the greatest common factor between those is the smaller of the two powers. So I'm going to just take out a to the 1 power, simply a. And we're going to do the same thing for the b component. Right, we have b's in common, b and b squared. So again, you take the smaller of the two powers to get the greatest common factor. So 5ab is what we're going to take out of that binomial. That's the greatest common factor between the two terms. Then we're going to put a pair of parentheses. And we're going to ask the question, okay, what times 5ab, that's what we factored out, is going to give us 5a cubed b minus 25ab squared. So we know we're going to have a minus sign right here because there's a minus sign in our original polynomial. So we got two blanks to fill in. The first blank, before the minus sign, we have to ask, what times what we factored out, 5ab, gives us 5a cubed b? Well, we know that's simply a squared, right? 5ab times a squared will give us 5a cubed b. And then after that purple minus sign, we have to figure out, okay, what times 5ab is going to give us 25ab squared? Well, first of all, think what times 5 is going to give you 25. 5. And you're going to pick up your A, that blue A in front. And then you have to think about what times your green B in front is going to be the B squared. You need a B, right? Yeah, so 5B times 5AB is going to give you 25AB squared. There you have it. This is your factorization using GCF of 5AB. Okay, here's a number 2. 27 x squared, y to the 4th, z to the 11th, minus 18, x to the 3rd, y squared. So we want to figure out what is in common between those two terms. So we have a binomial. What's in common between the two terms? So focus on the coefficients, the numbers. Can you divide anything about 27 and 18? Yeah. You want to pick the largest number. What's the largest number that can be divided between 27 and 18? How about 9? How about the x's now? They both have x terms in common. So remember to find the greatest common factor for variable terms. You have to take the minimal power. So we're going to take x squared. the smaller of the two powers. Then for the y terms, y to the fourth and y squared, we're going to take the smaller of the two powers, y squared. They don't have a z in common. So the first term has a z, but the second term does not have a z. So there's no z in common, so we're not going to take a z out. So our greatest common factor is 9x squared y squared, and then we have to figure out, okay, what's left over when we pull that greatest common factor out. So we're going to have something in parentheses. We're going to have a minus sign we're going to bring down. It's going to be in the middle. So we're going to have two terms. One in front of the minus, one after the minus. So the first thing we want to figure out is what times 9x squared y squared, our greatest common factor, gives us 27x squared y to the fourth, z to the 11th. Well, first of all, what times 9 gives you 27? 3. You're already going to pick up your x squared from that blue in front. You're going to pick up, well, you have a y squared, a green y squared in front there. So the question is, what times y squared will give you y to the fourth? And the answer is y squared. And then you also have to include a z to the 11th. Z to the 11th. So after the purple minus sign, you have to ask the question, what times 9x squared y squared gives you 18x cubed y squared? So first of all, focusing on what times 9 gives you 18, that's 2, right? 2 times 9 is 18. And the question is, what times x squared gives you x cubed? That's going to be an x. And you're going to pick up your y squared that you need in front of the purple parentheses with the greatest common factor. So that's all we have here for a greatest common factor. Factorization. How about a number 3? How about we have a tree times a house plus a tree times a car. It's supposed to be a car. Well, what do we have in common here? Notice there's a tree in common. So we're going to pull a tree out front. Then we're going to make a purple pair of parentheses, and notice that the operation here in between those two terms is a plus. We have to figure out, okay, what goes in the first blank before the plus sign? Well, what times a tree would give you a tree times a house? Well, a house, right? And then after that plus sign, we have to ask the question, what times a tree gives you a tree times a car? Well, a car. Now there's your factorization. So the greatest common factor was a tree, and then in parentheses you have a house plus a car. All right. Might seem like a silly problem there, but it's actually useful, I think. Let's say we have 2a minus b 7x plus 2a minus b 4y. So I'm going to tell you that this is actually a tree problem. Number 4 is a tree problem. There's some tree in common between two terms. So if I think about this as my first term and this as my second term, I'm going to say there's a tree in common. The tree, in quotation marks, turns out to be this guy, 2a minus b, 2a minus b. That's what's in common. Yeah, so both of those terms have a 2a minus b. So I'm going to take a 2a minus b. I'm going to take a tree out front. And then we have to figure out what's left behind in a pair of parentheses. Notice that in between your two big terms, you have a plus sign. So we're going to put a plus sign here. So first of all, I have to ask the question, what times the green 2a minus b is going to give us 2a minus b 7x? Well, 7x. And then after that plus sign, I have to figure out what times that green 2a minus b is going to give me 2a minus b times 4y. And the answer there, of course, is 4y. There we have it. There is our greatest common factor factorization. All right, let's do a number 5. Number 5, how about we have 5x minus 1, 14a squared, minus 5x minus 1 times 2a. I'm going to tell you this is another tree problem with a twist. So we're going to think about this as our first term, and this is going to be our second term, and we have a minus symbol, right? A minus symbol between the two. So what's in common? What's the tree here? What's the big tree? 5x minus 1, right? That's in common between these terms. I'm going to take out 5x minus 1 out front. We're going to have a purple pair of parentheses, and notice we had a minus between these two big terms. So I'm going to put a minus here below. Have to ask the question, what times green 5x minus 1 gives you 5x minus 1, 14a squared? Well, obviously, 14a squared I have to write. Then I have to ask the question, so after that minus sign in parentheses, what times 5x minus 1 will give me 5x minus 1 times 2a? And the answer, of course, is 2a. Okay, so it turns out I'm not entirely done. So what's in the purple parentheses? Actually, it turns out there's something in common. Actually, it turns out when I look here, in the purple parentheses, there's something in common. Is there anything in common between 14a squared and 2a? Yeah, so first of all, there's between 14 and 2, there's a 2 in common. So I'm going to copy down my 5x minus 1 from earlier. That was my tree. But then out of 14 and 2, I'm going to take out a 2, right? That's the greatest common factor there. And then I got to think about, oh, how about anything in common between a squared and a? A squared and a. Yeah, there's going to be an a in common we can take out, right? The minimal power is going to be a to the 1, so a. So then I'm going to make another purple parentheses. And because there was a minus sign here, I'm going to put a minus sign. Now I'm going to figure out, okay, what goes in the blank for the minus sign? So the question is, what times 2a is going to give me 14a squared? So first of all, what times 2 gives me 14? Well, 7. And what times a gives me a squared? Well, a. So that's 2a times 7a would give me 14a squared. All right, now what about after the minus sign? What times 2a gives me 2a? And the answer here, of course, is 1. Yeah. Now here is our final factorization using greatest common factor method of factorizing.